Language models are escaping their chat windows. Software developers are actively wiring them into the open internet, granting autonomous agents the physical ability to execute code, send emails, and move money. To measure the speed of this integration, the UK's AI Security Institute monitored public model context protocol repositories, the central distribution hubs for these agent capabilities, from November 2024 to February 2026. They captured a massive empirical dataset. The telemetry covers over 177,000 distinct tools engineered specifically to give AI agents access to external systems. This line chart plots the adoption rate over that 16-month window. Monthly downloads for these tools jumped from 80,000 to over 14 million. Policy researchers typically rely on isolated laboratory benchmarks to predict what AI might do in the future. This data records what developers are actually forcing AI to do in the wild, right now. The lobs reveal 3 systemic shifts: a pivot from passive analysis to unconstrained action, a sudden entry into high-stakes financial execution, and a recursive loop where AI models are now writing their own tools. The dataset confirms that the focus has moved away from isolated text generation. We are now tracking the live deployment of an autonomous digital infrastructure. On its own, a large language model is mechanically constrained. It predicts text within closed servers. It cannot click a mouse, read your live calendar, or initiate a bank transfer. The Model Context Protocol, or MCP, is the open standard engineered to solve this limitation. An MCP server operates mechanically as a universal plug. It wraps a specific external service, like a web browser, and translates its functions into a format the isolated agent can trigger. Developers publish these protocol servers on open platforms like GitHub. When developers download an MCP to wire into their agent, they leave a public telemetry trail. Aggregating these downloads lets researchers see exactly which physical capabilities developers prioritize giving to AI models. The AI Security Institute, collaborating with the Bank of England, ran a deep dive analysis on this telemetry to map the real-world capability ecosystem. These protocols are the literal bridges that grant an isolated neural network physical external agency. In early 2025, the tool ecosystem prioritized safety. Developers heavily favored perception and analysis capabilities. Agents were granted read-only access. They were permitted to read static local files or query internal, secure databases to assist human workers with research. This dual-line graph tracks usage. The red action-enabling line surpassed perception downloads in late 2025. The inversion is steep. Tools allowing agents to take direct actions in external systems grew from 24% to a dominant 65% of downloads. Taking action via a constrained API is predictable because the inputs and outputs are rigidly defined. Operating in an unconstrained environment requires the agent to improvise. Scheduling a calendar event through an API is a constrained action. Giving an agent direct, unconstrained mouse and keyboard control over an operating system is an entirely different risk profile. The telemetry shows that tools designed for these unconstrained environments now account for 50% of all general-purpose tool downloads. Within that general-purpose category, 95% of the downloads explicitly involve direct, system-altering action capabilities. This push for action is driven primarily by established corporate entities deploying production software, not just independent hobbyists experimenting in local environments. Agents have escaped read-only sandboxes. They are now executing consequential commands in the least controlled digital environments available. To evaluate the risk of these actions, the dataset categorizes the tools by the specific occupational domains they target. This pie chart maps the ecosystem by industry. Software development tools account for 67% of servers. Federal ratings classify these IT workflows as medium stakes, but hiding within the remaining data is an anomaly. A 14% slice is dedicated to finance. The financial sector breaks the safety pattern, targeting high-stakes occupations like accountants and traders. This sector is scaling rapidly. MCP servers built for payment execution grew from 46 in January 2025 to over 1,200 by January 2026. Inside that financial subset, there is a heavy concentration of autonomous cryptocurrency tools natively embedded for agent use. Cryptographic transactions introduce a unique risk profile. They bypass traditional banking delays and provide agents with direct, instantaneous, and strictly irreversible wealth transfer capabilities. While 90% of agents act as harmless IT assistants, a compounding subset of the network is being armed as autonomous, irreversible financial actors. Technology policy assumes that human software engineers are the ultimate bottleneck. The belief is that AI capabilities can only expand as fast as human developers write the integration code. The AI-SI telemetry dismantles this assumption. AI models are already actively authoring their own external capabilities. The data reveals that distinct AI authorship assistance was detected in 29% of all published MCP servers. The velocity is striking. The share of new tools written with AI assistance jumped from 6% in January 2025 to 55% by January 2026. The primary driver is Claude Code, responsible for 66% of these servers, followed by Cursor and GitHub Copilot. This establishes a recursive loop. A reasoning model writes the code for a new MCP server. Once published, that server permanently grants future models entirely new physical abilities. Traditional software lifecycles require slow, manual human quality assurance and phased deployment. This loop bypasses that latency entirely. Tool creation is no longer constrained by human engineering limits. The AI network is now actively coding the infrastructure it needs to expand its own reach. Geographically, this compounding ecosystem is heavily concentrated. Approximately 50% the capability infrastructure is currently live and scaling. The migration from safe, read-only analysis strictly into unconstrained browser and desktop control has already occurred. That control now extends to the explosion of irreversible, high-stakes financial execution tools operating in the wild. The entire agent ecosystem is now self-propelling and recursively compounding. Because agents are directly writing the integration code they will later utilize, the timeline for future capability leaps has shifted from years to months. The AI-SI findings reveal an ecosystem that builds its own access, moves its own capital, and operates outside of human-controlled sandboxes. By automating the creation of their own tools, these agents have removed the final human constraint on their own expansion.